Now, the first section of Chapter A lists out basically, the components for a hypothesis test. And it actually is kind of building you toward getting ready to do a hypothesis test. However, there's not an actual full hypothesis test till you get to the next sections of homework, where we actually put all the components together in a problem. So this is just kind of getting you ready to embrace, those components. But of course, we looked at earlier a hypothesis. A hypothesis is just a claim about a statement of a property of a population parameter. So you might see like some examples down here, the mean body temperature, and this is talking about like the population mean, right? The mean of everybody in the world, every human's body temperature is 98.6. Well, that would be a population mean claim. And a lot of times when we go to representing this symbolically, especially for when we go and enter it in the calculator later, we have to have symbols such as equal, less than, greater than. So we would write a symbol form for this. Mu less than 98.6 would be how you express that symbolically. Next, like the claim that the proportion of children that prefer the helper toy is larger than 50%. Okay, that would be like the percentage of all children, right? It's a population proportion. We're going to use a symbol P, just like we did with Chapter 7, for population proportion, right there. And then a hypothesis test, of course, is a formal test, formal procedure that we'll go through. Learning about how do we test the claim using sample evidence for some of these claims like above. And we'll see that as we go throughout. But first we got to get all the components ready. Now the first big component is something we call the null hypothesis. Okay? And a lot of times on the homework you'll see it with an H with a little zero beside it, H sub 0. So that is your null hypothesis. Okay, it's a statement that the value of a population parameter is equal to a claimed value. Okay? H sub 0, the null hypothesis, always has equal in it. So a couple things we're going to note about it is the null hypothesis is what we test directly, or in our calculator, what the calculator tests directly. We always assume it is true, and then we work from there. Like, do we have enough evidence to support or reject that null hypothesis? And then, yes, we are either going to do one of two things. We are going to reject the null hypothesis, so, we found enough evidence against it, or we're going to fail to reject it. Okay, as our initial conclusion for our hypothesis test. Okay. Now the alternative. So if the null hypothesis is not true, what will be the alternative? Well, the alternative hypothesis, and a lot of times it's denoted with an H1, or even sometimes you might see it with an HA. It's a statement that the parameter of values somehow differently from the null's value. Usually you're going to have, since the null has the equal sign in it, you're going to have one of three symbols: a less than, a greater than, or a not equal symbol that you use to represent the alternative hypothesis. And one of the biggest things you're going to come up against first is making sure you can set up the null and alternative for some kind of claim that they give you in a problem. Okay, you've got to be able to do these two steps, because if you can't, you won't be able to enter the right information in your calculator. Okay, so here's 3 steps that I use, and you'll see this in some examples below. I use these 3 steps to set up my own null and alternative hypothesis. Okay, first you want to identify the claim to be tested. So I always term this as the original claim. So I just call it my original claim. You'll see that a little bit later when we look at some problems. The original claim. Okay. And then we give it some symbolic form, because when we enter our calculator, we do have to have it in the symbol form. So right here, this says with the gender selection drug, the proportion of girls is greater than 0.5 that occurs without any treatment. So how would we represent that statement in a symbolic form? Well, proportion, that's P, and then greater than 50%, you'll do greater 0.5. And that would be the symbolic representation of that underlying statement. Now, next, okay, you want to give something called, or give a symbolic form for something we call the opposite claim. Okay, that's what I'm going to call it. The opposite claim is just whatever the opposite of your original is. Like if your original is not true, well, what will be true? If P is not greater than 0.5, what does P have to be? It has to be less than or equal to 0.5. So it has to be one of those. And that will be the opposite claim right there. Okay. Now, once you get step 1 and step 2 done of, trying to establish your null and alternative, you're going to finally figure out which one of those is going to go toward the null and which one is going to go toward the alternative. So the null hypothesis, okay, how do we know what the null hypothesis is? The null is the claim from the two above that has equal in it. So you want to look for the one that has the equal sign in it. If you look above, okay, so remember the original, this is your original right here, and your alternative, or your opposite, your opposite is down here. Well, the opposite, if you look at it, it has the equal in it. Right here underneath, you can see the equal sign. So this has the equal. So what's going to happen is, this one is going to shape our null hypothesis. The opposite claim will be our null. Okay. So we see the opposite claim has less than or equal. The equal is really what we care about. So when we write it down, we're always going to write it with just the equal sign. And here's how it's going to look. P equal 0.5. So you don't have to worry about the less than part of the less than or equal, just the equal. And that's how the null is always going to be put. Now the other one, the alternative hypothesis, HA, that's going to be the claim from the two above that doesn't contain the equality. So it's the one that does not have equal sign. Okay, we see from above that the original is going to be that one. So if you look back up here, this one right here doesn't have equal, so no equal, and it was our original claim. Okay, so our original is actually going to be the alternative hypothesis, and you actually just write it down like it is. You always write the alternative with a less than, greater than, or not equal symbol. For us, it's going to be greater. So we're going to write P greater than 0.5. One thing to keep in mind is the alternative hypothesis will always have one of these three symbols, whereas the null hypothesis, the null always has equal. And that's often a good way to eliminate some choices on your assignments in the homework. You can get rid of you can get rid of answers that have H0 having a symbol that's not equal sign. You can always get rid of those choices right there. Okay, so in the problems below, we want to identify the null and alternative. Just give you some practice going through these steps that I just highlighted, so you'll be able to do it your own self when you're starting to do your own hypothesis test. Right here it says we want to identify the null and alternative for these following examples. Now, part A says, dot dot dot. So you usually have some data or some sample that you've tested or gathered, whatever, blah blah blah, and then test a claim that the proportion of drivers who admit to running red lights is greater than 70%. Okay, so we're trying to see, is somebody maybe claim that the percentage of people who run red lights is more than 70% of people. Well, we can actually use data we collected, to test that. Maybe we ask people around in our college, like, do you run red lights or not? Whatever. But anyway, okay, so what we're going to do is test a claim the proportion of drivers is greater than 0.7. That is going to be my original claim. So I want to write a symbolic form for that. P is greater than 0.7. Okay. Now, of course, if that doesn't end up being true, well, what will be true? And this is what we're going to call the opposite claim. The opposite claim is just the opposite of the original. So if P is not greater than 0.7, what will P have to be? The proportion will have to be less than or equal to 0.7. Okay, and now you are actually ready to set up your null and alternative, which is what the problem is asking us to do from the information that we have. Okay, which one is going to be your null? Well, the null is the one that has the equal. This, the original, or the opposite claim here, has the equal sign. So we're actually going to write P, and we only use the equal part of the less than or equal 0.7. That'll be our null hypothesis, which means the original claim will have to settle for my alternative. P is greater than 0.7. And there's your null, and there's your alternative for this hypothesis test problem. Okay. And then, of course, going forward, we need more machinery. We would go ahead and enter our sample data into our calculator and proceed by testing from there. Okay, and we'll get to that in a little bit. Let's do some more practice on just setting up the null and alternative first, because you got to make sure you're good at doing that before you can actually tackle problems. So look at B. We have a test to claim that the average height of professional basketball players is at most 7 feet. So we want average height is at most 7 feet. Okay, so let's do original claim and opposite claim first. Now, with the original claim, we want to test the claim that the average height is at most 7 feet. So average, what do you think that will be? Well, that will be a test or a claim about the population mean. So average right there, you're going to put a mean symbol for that. And then at most 7 feet. Okay, so at most 7. Okay, think about, if somebody said you can mow yards and you're going to make at most $7 doing it, you're going to make 7 or less. So it's going to be less than or equal to 7. So it won't go over 7. Okay, which means the opposite claim will have to be mean greater than 7. Right there. And then once you have those two set up, you are now ready to establish your null and your alternative based on the original and opposite claims. Okay, well, the null always has the equal symbol. So we know it's going to be mean and then equals, well, in this case, 7. But which one is going to be the one that forms it? Well, it's going to be your original claim that forms your null right there. Okay? And then that means your opposite claim will be the one left for your alternative. Okay? Right there. And a lot of times, people get caught in this situation where they're like, they read the problem and they're like, oh, the claim that's in the problem will always be my, my null hypothesis, or whatever. Which, sometimes that happens. Like in this problem right here, the original claim did become your null. However, there are times where the original claim is actually your alternative hypothesis, like in problem A. So you can't just read the problem and say, oh, the original's this, or the null hypothesis is this, the alternative is this. It's good to write out like this opposite claim, original claim stuff. At first, when you're getting used to it, once you do a few problems, you can do it in your head, or you don't have to write as much stuff. But for now, definitely. And then let's do one more example here. We want to use the data to test a claim. So claim that the standard deviation of IQ scores is equal to 15. So that original claim right there, since this is standard deviation, we'll use a sigma symbol and equal to 15, which means our opposite would be sigma not equal 15. And from that, you can set up your null and your alternative, which are just going to be, this one is the equal. So that's going to come straight from your original hypothesis right there. And then not equal will be your alternative right there. So that one's a little bit more straightforward than the previous two. But you get the idea. One thing to keep in mind too is when you're writing these out, you know, just something to like jot down for yourself. Just make sure you know this. But, you know, H0 always has equal sign. And then HA or H1, whichever one it has, always has, it either have less than, greater than, or not equal. So definitely some things to keep in mind right there when you're setting these up.